In this lesson, we're going to look at how to find the area of some complex figures. So what we're going to do is find the area of the shaded region. So in this picture, we're looking for the area of these shaded parts right here. In order to do this, what I would encourage you to do is look at what shapes you see. So in this figure, first of all, we see a big square on the outside. So I'm going to make myself a little workspace for our square. And I also see a circle on the inside. So I'm going to make myself a workspace for our circle. And to find the area of just the shaded part, since basically the square has the circle cut out of it, if we find the area of our square and then subtract the area of the circle, what is left over will be this shaded region. So that's what we're going to do. So area of a square, the formula is length times width, or you could say base times height. So length times width. The length in this case is 12, and since it's a square, the width is also 12. So 12 times 12 is 144. So the area of the square is 144 centimeters squared. I'm just going to circle that. So now we're going to find the area of our circle. So formula for area of a circle is pi times radius squared. And so we have 3.14 times the radius. Now they didn't draw it in, so I'm going to draw it in here. And if it's 12 centimeters all the way across, it would be 6 centimeters halfway across. So our radius is 6. So we're going to have to do 3.14 times 6 times 6. And when you do that, you get 113.04. And that would be centimeters squared. And again, I'm going to circle that. So we have the area of our square and we have the area of the circle. So to find the area of just the shaded region, now we're going to subtract them. The bigger one is the square, so we're going to do 144, minus the smaller one is the circle, so we're going to do 113.04. So we're going to subtract those numbers, and we end up getting 30.96, and this would be centimeters squared. So the area of the shaded region is 30.96 centimeters squared. All right, let's take a look at another one. So again, we're going to break this complex figure down into the shapes that we see. So the first shape I see is this big triangle at the top. So I'm going to make myself a workspace for the triangle. The next shape I see is the rectangle on the bottom. So I'm going to make myself a workspace for the rectangle. And if I can find these two areas, the area of the whole figure would be just adding them together. There's no holes in this picture, so I'm just going to add my two figures together. So let's start with the triangle. Formula for a triangle, area of a triangle is 1/2 base times height. So in this figure, the base would be this right here, which is 3 plus 7, which gives you 10, times the height, which is right here, and that is 4. So if we work that out, half of 10 is 5, times 4 is 20. The area is 20 inches squared, and I'm just going to circle that. So now to find the area of the rectangle, that formula is length times width, or base times height. And the length is this distance here, which would be the 3 plus 7 again, so that's 10. And the height is 4. So 10 times 4 is 40. So the answer is 40 inches squared. So now to find the area of the entire figure, okay, the whole thing, we would just add those two areas together. So we have the area of our triangle, which is 20, plus the area of the rectangle, which is 40. And when we add them, we end up getting 60 square inches. Another example. In this one, if we break it down, we have a rectangle. So I'm going to make myself a workspace for the rectangle. And we have a half circle. All right, the formula for area of a rectangle is length times width, which in this case would be 6 times 9, which is 54. So the area is 54 centimeters squared. The area of the circle is pi r squared, so that would be the area of this whole circle. So if I can get the area of the whole circle, all I would have to do is cut it in half so that I know what just that region is there. So we'll do the area of the whole circle. So area is 3.14 times the radius. So I have to know what the radius is. Well, it's 6 centimeters from here to here, which means this is 6 centimeters. So just getting the radius from the middle to the outside then would be half of that, which would be 3. So the radius is 3. So we have to do 3.14 times 3 times 3. And when you do that, you get 28.26. Now that's, again, the area of the entire circle. So just to get the half circle, now I need to divide that by 2. So I'm going to divide it by 2, and I get 14.13 centimeters squared. So now to find the area of the entire figure all together, I'm just going to add my rectangle to the half circle. And when I do that, I get 68.13, and this would be centimeters squared. So that is the area of this whole figure. All right, our example. So again, we're going to break it down into the pieces that we see. The first thing I see is the circle on the outside. And the second thing I see is the triangle on the inside. All right, let's start with area of a circle. So area equals pi r squared. So that's 3.14 times the radius. So the center of the circle is here. To the outside is 4. So I have to do 3.14 times 4 times 4, which is 50.24. And that would be yards squared. All right, the area of a triangle. That is 1/2 base times height. And the base of the triangle would be 5. And the height of the triangle is right here, would be 4. So to work that out, half of 4 is 2, and 2 times 5 is 10. So the area of that triangle is 10 yards squared. So then finally, to get the area of just the shaded region, we need to take the area of the circle, because that's the bigger figure, and subtract out the area of the triangle, since the triangle is kind of like a hole in the circle. So when I subtract them, I end up getting 40.24, and this would be square yards. So that is the area of the shaded region, 40.24 square yards. And those are some examples of how to find areas of complex figures.